Okay, welcome, Shaul and Heather and Marissa and Robert and Ashley and Michael and Rebecca and Matt and Bros, and Julian and Delissa and Prakash and Joe Winter. Thanks for coming. This is our week 2 webinar. So it's our second regular webinar. Orientation's different. And we're going to be dealing with decimals, fractions, and percents today. That's kind of the deal, and I'll go over what we're talking about in a minute. But I want to mention a few things. One is that I just want to remind you that please, anytime you have questions, unmute yourself, ask a question, or pop in the chat box, whatever you feel more comfortable with is the way you should ask a question. Another is you can take a look at the discussion post for, drank the water the wrong way. You can take a look at the discussion post for this week. I always do a model post, and I also reply to myself, but don't reply to yourself. That's important. So there's a discussion post, and I'll reply to myself. You reply to somebody else. I only reply to myself so that you can kind of see what it looks like in terms of what a solution might look like. That's why I do that. And unlike last week, don't reply to more than one of your classmates. That's really important, because if you reply to 2, then someone else is lost out, because then there'll be a post that doesn't have, they'll get to the point and there's no post to reply to. Does that make sense? They call that the pigeonhole principle, actually, is that if you pick 2 pigeonholes and there's just a right number of pigeons to be in there and one takes 2 of them, then somebody's a loser, right? So make sure you only reply to 1. So that's just a note about the discussion post assignment this week. Whereas last week you could apply to everyone because it was just kind of fun. But this week is solving a math problem. And once someone solved it, you shouldn't solve it. Okay. And if it's gonna take you a while to solve it and you don't want anyone else to do it, then you can reply saying, I'm working on this. And then you can reply to it with your answer. And then if you want, you can get rid of the I'm working on it if you want. And that way someone else doesn't sneak in while you're not looking. Does that make sense? A couple little things about the discussion post assignments. And it's not that long. Another thing is what I recommend is make sure that you do your own on paper, okay, not on a computer. So in other words, before you post the discussion post, make sure that you solve your own problem. And if you can't solve the problem, then it may not be a good problem to give. Does that make sense? Okay, and I know there's a weird time, there'd normally be no issue, but if you happen to be around someone else, and we're not like allowed to be, I guess, but if you have family or something, show it to them, see if they understand what you're asking. Okay, or you could even, like, I don't know, Skype with someone about it, because you're not allowed to talk to friends anymore in person, but you can Skype with them. So show it to them, make sure it makes sense to them before you post it, and then you'll know that it'll make sense to you. Does that make sense? Okay. Another thing that I want to mention is if you do it by Wednesday, if you do your initial post by Wednesday, I'll take a look, and I'll probably look at them tomorrow on Wednesday. I usually don't look at them until after this particular webinar. And then if it works out, that's fine. I won't do anything. And if it doesn't work, I'll reply to yours saying, this didn't really work. You might want to think about reposting with a problem that can be done, that kind of thing, or it's just too confusing or something like that. So if it's done on Thursday, then I don't do that, and then I just take off points, which is much worse. So I give you kind of motivation to do it a little early, and that helps. Any questions about that so far? Okay, let me talk about what we're doing today, and I'm going to screen share. Okay, so here is the agenda. And what we're going to do is we're going to be looking at taking a fraction turning it into a decimal, taking a decimal, turning it into a percent, taking a percent, turn it into a decimal, then taking a fraction, turn it into a percent. Okay, so we're going to be looking at that. And I want to let you know I never take away a calculator, but you have to know what to do with the calculator. That's the key. And sometimes that could be tough. And the calculator I often use is the just the URL bar on Chrome on Google, because it does it, and I'll show you that, and you'll be able to see that. But whatever calculator, especially a computer calculator, because that's what you're going to have on the on the exam, or any regular calculator too. But you always have a computer with you. Then the computers will do the calculation if you know how to type them in. But if you don't know how to type them in, they don't do it. So it's important that you know how to use your own calculator. Then after converting, we're going to compare. So we're going to look at comparing decimals. And comparing decimals really means comparing anything. Okay, that's why I say other comparing, because as we can see from the first part, we're going to learn how to convert. If you have a fraction, you can turn it into a decimal. If you have a percent, you can turn it into a decimal. So the important thing is you know how to compare decimals, because if you know how to convert and you know how to compare decimals, you can compare anything. So that's what we're going to be looking at. And then what we're going to do is we're going to look at histograms and percents and decimals. We're going to look at pie charts and percents and decimals. Okay, so in other words, how do you read a histogram and figure out a percent based on the histogram of one of the pieces? And same thing with the pie chart. If you have a pie chart and it shows you percents, we got to get decimals, or vice versa. Or if it shows you full numbers, we got to get that. So that's the plan. It sounds like a lot, but it's actually not that bad. This class does not start that hard for most people. There are going to be a few sections later that might be a little hard, but this one's usually not the first couple weeks not too bad. It's kind of ease into it. But again, everyone has their own things that they have difficulty with. And I let you know I did grade your assignments this morning in terms of your discussion posts. The most important thing is if you didn't watch the orientation, you get dropped from the class. So you better contact me right away or you're just gonna get dropped. Okay, I haven't done the drop slip yet, but I will soon. So I put that on your grade. I just gave you a 0 for the discussion because you're gonna be dropped from the class, you don't get points of anything. Just let you know that. So it's very important that you did the orientation assignment, which is either go to it live or give me the 5 pages of notes. Okay, and if I responded to you that said it was good, then you know you're good. Okay, but again, look, many times I'm sending emails and letting people know, hey, you got to do this. It's not a maybe kind of thing. It's an absolute. So any questions about anything? Any questions? Okay, so what we want to do is want to learn how do you convert from one thing to another. Okay, so you want to convert from, say, fractions to decimals. Okay, and it's not that hard, but you have to know how to do it. That's the thing. And what I'm guessing, and I'm not sure about this because this actually, honestly, is my first time I've taught this class online. I've been teaching online for like, I don't know, over 10 years, maybe 15 years. I've taught this class before once. Okay, so Heather has a question about the quartile problem that's on the homework. So I'm going to let you know, I wrote a lot of these problems, and they are random. The numbers are random, even the problems can be random. So you need to give me a little more information than that quartile problem because there's a lot of those in the. So if you could, you can type in the problem, then I can definitely do that for you. Okay. And maybe I'll give you, maybe I'll do something and then you can look while I'm talking and then you can find that out. All right, let me, let's see if you're not muted already, because we're getting some feedback. And remember, unmute yourself if you want to talk. Okay, but sometimes you get feedback or people in the background or whatever. So it's better to mute yourself unless you're going to talk, and then don't mute yourself. Okay, so first thing, I'm just doing a basic math example, and then we'll get some application examples too. So first thing is convert the fraction, and let's make it look pretty. How about 12 over 162 to a decimal. And let me make that bigger. That's better. All right, so we have a fraction, and we want to turn it into a decimal. And let me say a little more, rounded to 3 decimal places. And I want to let you know when you're doing the homework, it's going to usually tell you how many decimal places to round. You need to pay attention. Okay, you need to round whatever it says. If it doesn't tell you, give a lot of decimal places. But most of the time it'll tell you, and you have to like do what it says. Okay, so the good news is this isn't too bad. So Heather, I'm going to finish this and then I'll get to your question, okay? It's weird to stop in the middle. So this isn't too bad. We have 12 over 162. And if we want to turn it into a decimal, it's really easy. And by the way, we're always allowed to use a calculator. So unless, I don't know, your definition of fun is long division, that is not my definition of fun. Use a calculator. I'm just going to use the, I'll just use Google's calculator. I'll just show you how that works. I'll just pop on a new, let me remember the numbers again. So that was 12 over 162. So all you do is you go 12, and then you hit the slash, you go 162. Let me do that again. And it just gives it to you. That's what I like about Google. Okay. If you have your own favorite calculator, that's fine also. And notice it gives you a lot of digits. 0.07474. I'll just write that many. That's enough. So the first thing is 0. Just a minute. There it is. 0.0747. There might have been some more. 0.074074. Okay, is that the answer? What do you think? Any thoughts? No, because we didn't read the instructions. We need to round to 3 decimal places. So the 3rd decimal place is right here, this 4. And then the check digit is the one to the right of that, which happens to be a 0. So that means that rounded to 3 decimal places is 0.074. And that's the answer. So it's one of those things, especially you can do most of your work on computer, and computers, they're not friendly when you make a little mistake. If you forget to round, you just get 0 points, and that's bad. Okay, so make sure you always read the instructions or it'll bite you. Okay, that includes the exam, by the way, too. So you have to do it right. So always read the instructions. Okay, so now answer this question. So let me read it. And it's in the chat, which let me put it here. And that is the first quartile is the value such that 25% of the data falls below that value. Okay, suppose that there is a 0.24408 probability that employee will call in sick less than 3 days in a year. Is 3 below the first quartile or above it? Okay, so the key on this one is we need to round this number and take a look. And the key is we're comparing 25% to 0.24408. So this is something that it's actually on the list of things to do today. Okay, so this is the homework that's due this week, which is what we're talking about. So the first thing is I'm going to take the 25%, I'm going to turn that into a decimal. Now, does anyone remember from your past life how to take a percent and turn a percent into decimal?
Divide it by 100.
Yeah, we divide it by 100. I think the easier way of doing it is the first word that you said, which is move.
Yeah.
Move the decimal over 2 places to the left. And you can write as, if you want, 25.0%. That's fine. Decimal place. Move that decimal over 2 places. And what you get is 0.25. If you want 250, it doesn't matter. Any questions so far?
No.
And we want to compare it with 0.24408. Is that clear? Okay, so we're going to compare it with 0.24408. What is a quartile? Okay, so let me tell you. The first quartile means that 25% of the data falls below that value. So you actually don't have to know the word because it just tells you. Do you see? Does that make sense? Actually, it defines the quartile in the sentence.
Well, I think that's why it was more confusing, Larry, is because it has all the new language in it. So I had to watch a video what a quartile was. And then I can definitely compare the 0.24408 and the 25%, but then you got the probability that the sick days are less than 3 years. I think it throws.
Yeah, so let me finish, and that hopefully that'll make it really easy.
Okay.
Does that make sense? So we're almost done. So can we compare which is bigger, 0.250 or 0.24408?
0.25.
Yeah. So what we can say, I'm going to write it as 0.24408 is less than 0.250, which, by the way, was 25%. Is that clear so far? Okay. So less than, another word for less than is below. Is that clear? So that's the key on this one, is that another word for less than is below. Okay. So let me highlight below. Does that make sense?
Yeah.
So that means, so therefore, 3 is below the first quartile. Is that clear? Any questions on that?
No,
okay.
That I've watched it now.
What's that?
I said, now that I've watched, we'll listen to you explain.
That makes sense?
Yes.
Yeah, and what I want to let you know is that, remember the whole purpose of this class?
I think it's just to do the math, right? Not listen to the whole.
The purpose of this class is to pass your statistics class when you take it.
Yeah.
So you're going to be getting a lot of stuff, or at least some stuff, a week on it, on quartiles. And the idea is this will bring you one step ahead when you get to that point in your stats class. Is that clear?
Yeah, watching the con video on what the quartiles are. Explain a lot. Yeah, so that and you explaining this helped out tremendously.
Yeah, so what I've done, and again, this is all about subliminal messaging, is I have tricked you into watching some statistics videos.
Yes.
So it worked. Because remember, that's my whole purpose, to get you ready for passing statistics. It's not about passing this class, it's about statistics. So if you watch some stats videos, that's wonderful. Okay, because then you'll do better when you get to statistics. And that's for everyone, not just you, by the way. Okay, any questions on that? Any questions?
Thank you so much for explaining that.
No, it was good. And by the way, this is, let me move on up. So notice that number 3 was percents to decimals. So I was doing this anyway. Is that clear? So we've now done fractions to decimals. We've done percents to decimals. Let's do decimals to percents. Any questions on that? Okay, let's do decimals to percents. Because that's the next thing on the list, or one of the things on the list. The order doesn't matter that much. Okay, so it's very similar. If you want to convert a percent to a decimal, you move the decimal place over to the left. So if you want to convert a decimal to a percent, move decimal. Any guess? How are you going to move it? Yeah, and in fact, 2 places. Two places to the right. So here's an example. Suppose that the proportion of lefties is 0.124. Okay. And by the way, I'm a lefty. What percent of the population is a lefty? Okay. And what I recommend is all of you work on this. So I'm going to give you, some of you can do this like in a second. Some of you take a little bit more time, but I want you to work on it and make sure you can do it, and then we'll do it together. Okay, so I'll give you a few seconds to try. And a lot of times you get proportions using a calculator, and then you want to find the percent because that might be more interesting. And in stats, that happens a lot. You're going to use a calculator or a computer. Calculators and computers don't give you percents. It gives you decimals always. But often percents are what you want to use to understand. Okay. All right, ready? Okay, so what you do is you take this 0.124, you take that decimal place that's just to the left of the 1, and you move it 2 places to the right. So when you move that 2 places to the right, it goes in between the 2 and the 4. So what we can say is that 12.4% of the population, I guess, are lefties. Any questions? Any questions on this conversion? Any questions? Okay, so that's pretty important. Okay, pretty important to be able to do this. I want to give you another one that's similar to what Heather asked, but something that a lot of people make mistakes on, so I want to make sure. Okay, so let's suppose The level of significance for a study is 2.5%. Write this as a decimal. Okay, because this is one I'd say about 30% of my statistics students get it wrong. And I think part of it is because they don't even think. If you think, you'll get it right. If you don't, you'll get it wrong. So the key on this is promise that when you get to especially next quarter that you think when you have to do something like that. Okay, so what you have to do is to solve this, I'm going to write this a little bit differently. I'm going to put some zeros before that too, just have a place to move. 0.5%. Do you agree that's the same thing? It looks a little strange, but that's still 2.5%. But now when you move the decimal over, we have places to move it. So we can move that decimal to the left 2 places. And when you do that, the first time it's just before the 2, and the second time you get an extra 0. So that is equal to 0.025. Any questions at all on this example? Okay, do you have to know what the words level of significance means to understand this question? What do you think? Was that necessary? No. Any guess on why I put it in? Not to throw you off. That was a good guess, but no. No, it's the subliminal messaging. So I want to let you know that level of significance is a key phrase in statistics. So just keep that in your head. You'll hear it a lot. Okay, and I'll be giving it a lot so that when you get to stats, you'll start hearing this language. And then hopefully when you get to stats, you'll be so familiar with the words that you'll be able to use them once you learn what they mean. That's the hope. Because that's a big biggie in stats. We spend weeks and weeks talking about it, okay, and using it. Okay, any questions on that? Okay, are you ready for a interesting problem that's useful and depressing? Sorry. So I like to bring in, if I can, things in the news. Okay, any guess on why I say you're about to see something depressing? Any guess? No idea. The hint is there's only one thing in the news right now. Yeah, the virus. So I'm going to bring something about that, but I want to really analyze it, and we're going to be able to do what we're talking about to analyze it. So here's a question. What country is more dangerous in terms of the virus? The US or Italy? But before you answer, I want to show you something. So I believe you can see this, right? Yeah, you should be able to see this. Okay, so the article says, US leads the world in deaths as Europe slowly reopens. So what do you think? What country is more dangerous? Okay, you're saying Italy, but what did the article just say? What did it make you feel? Yeah, it makes you feel like the US. So what you need is not more evidence, you need more numbers. Okay, so here's the real question, and let's go back. Another way of saying that is which country has the higher percent, or actually I'll write of deaths. It's not number of deaths, it's percent of deaths that matters. Is that clear? Well, how do you find the percent of deaths? Any ideas? Okay, what you do is you find the fraction. Yeah, number of deaths. Actually, I'm going to look at number of deaths over number of people because that's more important. Number of cases, that's only if you have it. But if you don't have it, or if you don't know whether you have it or not, and you might be getting it soon, then the question is, what's more dangerous? So if you randomly picked an American versus randomly picked an Italian, which one has a higher probability of dying? Is that clear? Or having died in this case. So what we need to do is we need to do the not population times deaths. We need to go deaths divided by population. Any questions on that? So let's get our data. So first thing, number of deaths in the United States, 23,634. So let's write this down. 236. Let me write it down so I forget. That's the easy way. 23634. Okay. Anyone know what the population of the U.S. is? I'm sure no one knows the exact population because no one really knows. And so it is, it's a lot more than 30 million. It's over 300 million actually. Yeah, no, we're a big country. So it's 328,200,000. And that was in 2019. We're actually more now, but I'm going to use this data just because it was an easy one to find on the website. Okay, 328. $328,200,000. Now let's do Italy. And let's find the deaths in Italy. So all you have to do there, I think this page actually has it by country. There's Italy. And that is 20,465 have died. Okay. And the population of Italy, let's see what that is. So that was the population of US, now let's pop in Italy. Okay, and the population of Italy, 60.36 million. Okay. Any questions on that so far? Okay, so now we want to see, and I'm going to do a bunch of stuff because I like to use real life stuff, and this is about as relevant right now as it gets in terms of what everyone's talking about. So it's important to understand, what this stuff means. So first thing, let's look at the chance of dying in the United States. So if you're an American, what's the chance of being dead at this point? Because, if you randomly picked an American, what's the chance that American died? Okay. Well, what do? We take the fraction. Well, we take 23634. And we divide by 328. 200,000. think I got one too many zeros. There we go. Any questions on that? Okay, and then Italy, by the way, same idea. And that's going to be 20465 divided by 60360,000. Okay. Now you might be able to know just by looking at it, but these numbers are awful, aren't they? This is why it's better to either have decimals or percent. This is much easier to see. So let's do that. So I'm just going to copy this into what I call my calculator. And it says 7.2 e negative 5. Okay, what does that mean? And again, if you don't see the e negative 5, you will get it wrong every time. So always make your eyeballs move to the right, because this is going to happen in the statistics class over and over and over again, where you're going to have the e negative 5. Yeah, but how do I turn it into a fraction without using the e? Or no, decimal, sorry. What do I have to do? Yeah, I'm going to have to move the decimal 5 to the left. So I'm just going to write 7.2 because that'll be enough. E negative 5. So I'm going to write this out. So first thing, let's put it over here, 7.2. But I'm going to put in, instead of just 7.2, let's put in a bunch of zeros. So then I'm going to take that decimal and I'm going to move it 5 zeros to the left. Notice the first 5 points to the left. The first time I'm just in front of the 7. But then the other 4 times I'm going to grab a 0 out of it. So what I get is 0.000072. Any questions on this? Okay, by the way, and this is important, is this a big number? .000072. What do you think? Okay, hopefully you know this is not a big number. This is a tiny number, right? So your chance of dying in America from the coronavirus is really, really small. Okay, still death sucks, but the problem is that some people do die, and if we don't socially distance, more people will die. But you don't have to like be panicked because you're worried that you're going to die, because it's really, really small chance. But societally wise, it's better not to have a lot of people dying. Okay, even if it's a very, very small chance per capita. Let's also turn this into a percent. How do you turn this into a percent?
You would move the decimal point to the right 2 times.
Exactly. We move the decimal place to the right 2 places. So what we get is 0.0072. 2 of the zeros get killed, percent. So again, what I'm doing is I'm doing an example of converting these fractions to decimals to percents. And that's what this week is all about, is how to handle those different things. Any questions so far? Okay, now let's do Italy. And let's go into our Google calculator. Here, it doesn't make a scientific notation. It's 1, 2, 3 zeros, and then a 3, 4. That's 2 significant digits. Okay, let's convert that to a percent. So what percent do you get?
0.034.
Yeah. So we get 0.034%. So where should you be more scared? Italy or the United States?
Italy.
Definitely Italy. Okay, you don't even have a 1 in 100 chance of dying of the. You don't even have 1 in 100% chance of dying of the coronavirus in the United States. But in Italy, you have 3 in 100% chance. Do you see that? It's a huge difference. So Italy is definitely a scarier place right now than the U.S. Even though if you read the news, it makes the U.S. look much worse. I don't know if you've been watching the news about that, but they're making it look like the U.S. is the worst place to be, and it's not. Okay, and that's because we compare. So hopefully it's clear to you that 0.0072% is less than is less than 0.034. Is that clear? Okay, so therefore, the per capita rate of death is higher in Italy. Any questions on this? Okay, and it's much higher. Okay, it's not just less than, but it's much, or US is much less than. Any questions on that? Okay, by the way, I will post this on YouTube. You can watch this 100 times if you want. Okay, might drive you crazy though. Okay. Would the numbers be affected by the population distribution over the country? Well, if we're just looking at if we're looking at the national per capita death rate, then it doesn't matter where in the country, whether it's New York or Pennsylvania or California or wherever it might be. It doesn't matter where they're dying if you're just looking at America. I don't know if that's what you're asking. Okay, but if you want to compare, say, California to New York, then we do what we just did over here. And you could do that. Very similar. Does that answer your question? Here we're just looking at it by country. We're not looking at it different areas of a country. We're just looking at the country. Okay. And if that doesn't make sense, please ask. But I think that's what you're asking. Any questions on this idea? Okay, so now what I want to do is I want to look at histograms. Okay, do you guys know what a histogram is? Let's see if you can tell me, say it, or put in your chat box. What's a histogram? Any ideas? You've heard the word before, I'm sure. And it comes up in stats a lot, by the way. All right, well, if you don't know, let's do a histogram. And we'll do a histogram of something you're interested in. I don't know. Histogram of, definitely not oriented gradients. That's what Google wants to do. Yeah, it's a chart, and it's a special kind of chart. So let's take a look at an example. Let's do one that you might be interested in. How about histogram of majors? And see if I can find one. Google gives lots of images. Let me go grab images. There we go. Not doing majors, so let me do college majors. I thought this would be a lot easier and I was wrong. All right, we'll do a side-by-side histogram with men and women in it. Should be in here somewhere. I was looking for the one I made. There it is. Okay. All right, that's not a histogram, it turns out. So let's not do that one. Let's do this one, just for fun. It's not majors, but it's good. Let's do a histogram of unemployment rate, because that's a big thing in the news now. Of course, now unemployment rate is huge, but pretend we were in normal times. Then this is a histogram, okay? And we can look at the unemployment rate, and we can say that, for example, if you look at the 0.6 to 0.7% unemployment rate, that is a count of 25. Do you see that? Any questions on reading this histogram? Maybe I'll even make it bigger. Let's see if that'll work. There we go. Okay, so now it's a little easier to see. So do y'all understand how to read this? Okay, so now what I want to do is say, well, what percent of the population, okay, has between a 6% and 7% unemployment rate? So in other words, what percent does this bar represent, the 6.06 to 0.07 bar? Any questions on that? Okay, so to figure that out, what you need to do is you need to come up with a fraction. And the way you come up with a fraction is you take the height of the bar, and what is the height of this bar? What's the height of this bar?
25.
Yeah, 25. Okay. And you divide it by all the heights combined. So now we're going to divide by all the heights combined. How do you get all the heights combined?
You add them up.
You add them up. So it's a little bit of work. I'm going to write it down on paper. You can't too, so you can add them. So we're going to have the first one, I'm going to estimate, looks like about 6%. 6, not percent, just 6. The second one is 4. The third one is 9. The fourth one is 7. The fifth one is 15. The sixth one was 28. The next one was 25. And the next one was 22. And then came 19. And then came 16. Okay, and the bar we were interested in was the 25. Now let me go back to, we're going to start typing and stuff. So if we want to say what percent of the group has a 6 to 7% unemployment. Any questions on the question? Okay, and what we're going to do is we're going to first look at the fraction who have that unemployment rate. And the fraction is going to be 25. That was the height of the first part. And then divided by, and then you got to add up all those numbers. 6 plus 4 plus 9 plus 7 plus 15 plus 28 plus 25 plus 22 plus 19 and then plus 16. Any questions on that? And if we want this fraction, by the way, you don't have to, you know, you could do it in your head if you felt like it, but you probably don't. So what you can do though is I'm just going to copy and paste it right into Google. And it's 151, the denominator. Is that clear? So that's equal to 25 divided by 151. Any questions so far? All right, well, that's not a percent. That's a fraction. How do we turn a fraction into a percent? Okay, what's the steps?
You move the decimal point over to.
But we don't have a decimal point yet, so what's the first step?
You divide the 25 by 151.
Right, that's the first thing, is now we're going to go and we're going to divide 25 divided by 151. That gives you about 4 decimal places, and that's 0.1656. Let me write that out.
Mm-hmm.
And now we can talk about the percent. Okay, so if we want the percent to the nearest whole number percent, then let's first round to a percent. So to change 0.1656 to a percent, you move the decimal over 2 places to the right, and you get 16.56%. And now we're going to round to the nearest whole number. So the 6, that first 6, is the ones digit, the whole number's digit. The check digit, which is to the right of the 6, is a 5. So it goes up. And that gives you 17%. So any questions at all? Any questions at all on this example? Any questions? Okay, so that's its exams. And again, it could be a little bit busy like I had to do here. Adding up all the numbers takes some time, but you always have a calculator so you can do that. But if you don't know what to do with the calculator, it won't help you at all. Any questions at all? Any questions at all on this? And you don't have to use the Google URL bar calculator, but I don't know, it's just easy when I'm on the computer. Okay, the next chart I want to talk about, which happens in stats a lot, is the pie chart. And the nice thing is I always like to just do an example. Anyone interested in something about that might have a pie chart? Pop it in, we'll look at it. I don't see y'all jumping in. All right, well, if no one's interested in this thing, I'll make something up. Okay. How about pie chart of world population, see what it gives us. I'm just gonna make one up. Click that one. Let's see what it says. Just randomly pick one. Hopefully it's not obnoxious or something. Apologize if it is. I think it was this one. Yeah, let's look at a pie chart of continents. Okay. So let me ask you is how many people are there in Africa based on this pie chart? How do we find that out?
You add them up.
Yeah, but what do they have to add up to? We don't have to add them up. Because what do all the numbers have to add up? Yeah, they are going to add up to 100%. So we could add them, but we know we're going to get there. That's not going to help. Okay, what you have to do is you have to first be able to read what it says about Africa. What it says is 15% are in Africa. Do you see that? Then we have to say, well, how many people are there in the world? Anyone know? Hell of a lot, by the way. But that's not a good enough answer. Anyone know what the population of the Earth is? 60 trillion. Boy, we would be in bad trouble if it was 60 trillion, by the way. Yeah, I better look it up. So population of the world on Earth. How about population of the world 2020? 8 billion people. Okay. Yeah, we keep growing. Every time you blink your eye, there's a lot more. But by the way, we're not even close to 60 trillion. That would be the end of society, by the way. That would be very bad. Over 8 billion people. And so if we want to find out how many people are there in Africa, well, we know there's 15% Africans. There's 8 billion people. Let me write this out. Well, that's 15% of 8 billion. And you have to know how to write 8 billion. So that's 8 and then 9 zeros. How do we find 15% of 8 billion?
Divide it.
Not divide it. Yeah. What we're going to do is we're going to turn that 15% into a decimal. So if you don't convert the 15% to the decimal, it's really hard to do. So we convert the 15% to a decimal by writing this as 0.15 and multiply by 8 billion. Any questions on that? Any questions? Okay, and that is how much? It's 1.2 billion. And again, you can use a calculator. Maybe I should do it that way with a calculator. It's better in my head. Because I do not expect you to do this in your head, by the way. And it's 1.2 billion people. Where was I? Here. And so from that pie chart, we can actually find out, from the pie chart and knowing the population on Earth, we can find out how many people there are in Africa, approximately. You know, the exact number is impossible because there's always someone being born, you know, or dying. So that's, you know, you can't get that, but you can get an approximate amount. Okay, so it's a pretty big continent. Okay, I think it's around the same as the population of India, by the way, or China, maybe China, because they're similar to the 1.2 billion. Any questions at all on this? Okay, now I have something very important. Something, can I do one more with the same pie chart? Or do you want a different pie chart? Same pie chart. Okay. Maybe I'm not going to do it. I'm going to have you try doing it because that's more important. Okay. How many people are there in Australia? So the question is, how many people are there in Australia? And again, we're given this pie chart. Hopefully you can read that. Maybe I'll make it a little bigger. How many people are there in Australia? Remember, we're given the fact there's 8 billion people in the world, which I found by Google. And let's see if you can do that. I'm going to give you a minute or two. Okay, and it's going to be a lot fewer than than Africa, that's for sure. Okay, give you a couple minutes. And I like this one because it's got a decimal percent. So it makes you think a little bit. So how many people are there in Australia? Let's see if you can come up with it. And again, you're welcome to use a calculator if you need to. Okay. All right, so Shaul gave it a good shot. Let's see if it's right or not. Okay, so now I'm going to go do it. So we have 0.3%. And let's go back to kind of my area where I can do the calculation. So we have 0.3%. And how do I write 0.3%? How do we write that as a decimal?
0.003.
Yeah, you move the decimal over 2 places to the right. Sorry, to the left. And when you do that, we need to add another 0 there. So we can have get the 0 out of it. And then you get 0.003. And I'm going to multiply that by the 8 billion. And when you do that, you can use a calculator if you want. Okay, 8 times 3 is 24, but you got to make sure you get all the decimals right. But you get 24 million. Okay, here's a trivia question. Where were we? So here we got Australia. So is Australia the continent that has the fewest people? Nope. Antarctica. Good question. I think y'all know Antarctica has fewer people, right? But that's cheap because like almost no one's there. It's too cold. Okay. So what I want to do next, very important. So important, I'm going to make it bigger. And that's the secret word. There's probably no corona in Antarctica. I'm not sure. There are some researchers there. But my guess is there's none. Okay. So the secret word is decimal. Okay, because in order to do these comparisons, the first thing you have to do is convert to a decimal. Okay, if you have a fraction or percent, just convert everything to a decimal, and then you can do the comparison. Okay, because calculators handle decimals. They don't handle percents. And fractions are just hard. So I always like to make the secret word relevant to what we're doing, but not necessarily, like you're going to know for sure what it must be. So that's the secret word. And that is everything I need to talk about. I was trying to go around an hour, and we're at 7:03 right now. So I'm going to do 2 things. I'm going to stop share. I'm also going to stop the recording.